What
Yeah,
hotel
yeah.
is that?
Wow.
Elad, what hotel are you in?
What's that?
What hotel are you in?
Cosmopolitan.
Yeah, it's like Naria. Same image.
Exactly. Exactly.
Oh, I
All right.
see EJ. See, EJ is here. Hi, EJ.
AJ.
He's a silent participant, but he worked with me at Amazon before the CDK.
Wow. Before it was cool.
You know, it was actually at the team I used to be when we created this project before the CDK. He used the CDK before it was a CDK.
All right. So how about we get started?
Yes.
Yeah. So our goal today is to implement like a GCP bucket in Wing's standard library. So thinking of how much exposition to give. So the Wing SDK library is a TypeScript library, or it's implemented in TypeScript. So I guess, yeah, we're gonna start by first adding GCP as a target, by adding this target in the SDK library, and then trying to add the resource and see if we can create things just through JavaScript and TypeScript, and then later we'll get to, if we have time, figuring out how we can connect that to the compiler, because as you can imagine, you want to be able to say like, okay, Wing compile like -- target GCP and stuff like that. So yeah, I'm just gonna check, share my screen. Let me okay, so I'm just on the main branch. Yeah, and so here's all of our like the resources in the SDK. They're broken into two parts, and people on the team will already be familiar with this, but for people that are new, basically there's this abstract definition in this cloud namespace, and this is where we have like an abstract class. Like we have these two classes really for each resource, for some technical reasons, but basically these two classes abstractly define what a bucket should do across all clouds. And then we have another implementation in each of these like target directories. So what we're going to want to do is actually create like a new target directory. So we're going to say target GCP. And actually, let's also think of like how do we want to kind of play around with this. Practicing compiling from a Wing app would be nice, but like then I kind of have to wire the SDK in with the Wing compiler, and for me it's just easier to test with this little sandbox mechanism I've added here. So and this kind of resembles the code that Wing will be compiling to. So basically it creates one of these apps classes based on which target you're compiling to. So it could be Terraform for AWS. It could be a simulation target or so on. And then it basically initializes any constructs, and then it calls synthesize. And this is described, yeah, in a bit more detail in the SDK architecture document in our Winglang docs. So I can definitely answer any questions there, or if people have questions, I can answer them, or I recommend reading that as well. But yeah, so we're going to want basically like I think TF-GCP target, just to kind of match the conventions we have right now. And I did do a little bit of research beforehand. And one of the first things we actually need to consider is like, how do you create a resource on GCP? You know, and we're going to be doing that basically through like the Terraform provider. But it turns out every GCP resource needs to be part of a Google Cloud project. So let me actually show you my browser. So I'm in the Google Cloud Console, and has anyone else seen this before? Brand new? Okay, I hear some hands. I can't see your faces right now, so but yeah, so basically, if you have a Google Cloud account set up, you can basically create a new project through this. Or does someone want to ask a question? Okay, I'll keep going. But yeah, you can create a project through here, and let's see. And the other thing you have to do is you want to like connect it to like a billing account. I've already done that, but I guess I don't want to leak any sensitive information just in case. But I think you can do that basically through this billing tab, and it's like just a few clicks. So basically, every resource, when you're using the Google Terraform provider, like every resource needs to be associated with some project ID. So I've kind of already set that up. So
When you create a resource, you specify the project ID?
well, really, it's in the, it will be in the app class. So let's get into that.
Okay.
So to figure out what needs to be in the app class, I'm actually going to kind of steal from the code in our AWS target. So basically, what makes an AWS target unique? It's basically, we're specifying that for Terraform, we want to use this AWS provider, which is like just a Terraform declaration that says, I want to know how to access Terraform like AWS definitions. And we also set up this Polygon factory, which is basically the mapping from these resource classes, these abstract classes, to the concrete ones. So for example, here's this factory that says, if we get this string named wingstk.cloud.bucket, is actually going to map to this bucket class within the AWS directory, and vice versa for, and then the same for, you know, queue and counter and so on. So that's where all of these mappings are, and that's all this factory does, and people will be able to customize it in the future. So wait, so where was I? So we were looking at this app class for AWS. So basically, we're going to do the same thing for GCP. So yeah, I'll just import these things. We're going to have to create our own Polygon factory. Yeah, most of this can be imported. We don't want a AWS provider, we're going to need a Google provider. So I actually need to import that. So to add a dependency, we have to do that through the progen.rc file, which is this, it's like a configuration file. So I'm just going to add this here and then run npx progen. Oh, I haven't seen this. So that's not good. Feel free to just speak up if you want. Okay, so this is the error. Resolve dependency. Is it possible we're on like CDKTF 13.2, but we're trying to install the latest? Let me see if I can like, I'm gonna kind of fiddle with the package JSON here. But like, yeah, let's just try upgrading this and hope nothing breaks. No, that didn't work. Oh, it's because, yeah, this is very, NPM dependencies can be kind of hairy. So where is it resolving? Because the provider AWS. Okay, what's the latest version of this? 11? Okay, let's try 11.
By the way, Chris, I think that we should change eventually from using the pre-built providers to just importing the providers that we need. I think there's also even a way to import only specific resources from specific providers. You know,
Right.
you import like get, I think it's called CDKTF get. There's a command in CDKTF that basically generates constructs from a resource provider. And so instead of importing all of AWS and all of GCP, we can just import specific resources and they're going to be part of our code base, right? And so we remove this dependency altogether. It really will simplify the dependency story. And it'll also make the library much smaller, potentially.
Yeah, that's a good idea. Yeah, it'll also reduce our bundle size and stuff.
Yeah.
Okay, so now that is working, which is awesome. Okay, and this we actually need to create the factory. I'm also basically just going to copy that based on what we have in AWS, but of course we're only going to have one resource. I mean, let's implement it from scratch just to like kind of go through the motions, but yeah, Polygon factory extends Polygon factory. Okay, no, this is going to take forever. Oh, it's Copilot's already kind of auto-completing for me.
Next time it's also going to be part of your, going to also be joining our meeting and hosting it.
Yeah, I know. Where is this important? Okay, I just misspelled it. Oh, implements. Okay, I'm just gonna copy the implementation. But basically, yeah, we only want to resolve buckets right now because we're only going to implement one resource. And so, yeah, there's this like string constant that's like associated with each resource name. And that's kind of like how the dependency injection mechanism knows like what we're injecting for. And this is actually where we're going to need to, this is kind of to do basically. Well, I guess for now we'll just like, okay, we need to implement a bucket. Okay, so we can import that, blah, blah, blah. And let's just see if we can synthesize like an empty target, like with like an app with no resources. We should be able to synthesize that. Okay, so I'm gonna say import star as tf GCP from I should maybe rename that. Did I not name that? Yeah. We're just keeping this convention of like associating the targets with Terraform because in the future maybe we want to offer like other provisioning engines and stuff like that. Okay, unable to blah blah blah. Okay, I think we need to export it here. See. Okay, and here we need an index file. A bunch of these like TypeScript conventions. Okay, is that working now? Maybe. Okay. Okay, so that should work. Okay, yes. Okay, so we should be able to synthesize this totally empty app. So we have there's like a convenient command here for just synthesizing this main.ts file. Oh, and we don't have a logger. Let's ignore the logger. Okay, things compile. So, and we could kind of sanity check that further, like by adding like a print statement or something in the app, just if you want to see. But let's just take it for granted. Any questions like so far? I mean, it's kind of like setting a boilerplate, but I bet people are more interested in the bucket.
I think definitely we want to consider at some point removing some of that boilerplate with either code generation or some, because in Wing there's not going to be all this boilerplate is going to go away, right? Like when you will define a new resource in Wing, basically a lot of the stuff that you're doing here is going to be taken care of by the compiler.
Yeah, exactly. And yeah, we need to think of like how do you want to define a polygon in the Wing language? What the syntax for that will look like. But even for adding new targets, I think that will be a use case. Totally.
Yeah.
Okay, so let's start actually writing this bucket class. So what does it mean to implement? So basically, each of these abstract resources, we call them polygons because we're using this polygon framework we wrote. It's just like a dependency injection library. it's like a polymorphic construct. So to implement for the target, we're going to say export class bucket extends. I'm going to just import the type cloud namespace. Dot. We're going to extend the base class. And let's just, okay, and we already got some stuff for free. And we need a constructor. And here, you know, in TypeScript, we actually do need to type out the scope and ID and all these other things. And yeah, for now, I think we'll just assume like, so if we look at the props, what kinds of things can people configure for Bucket out of the box? Like what are we supposed to be supporting? Well, we're supposed to be supporting whether it's public or not. For now, let's just keep things simple and say like, okay, let's only support private buckets because we just want to, you know, have like the simplest thing possible to get started. So let's say, you know, if props dot public is true, or it's just kind of needed. My VS Code is like lagging a lot today. Not totally sure why. Maybe it's the screen sharing. Anyways, yeah, let's say like only private buckets are supported. Right, and so what is the actual code we want to generate? So we want to generate some kind of GCP resource that corresponds to this. So like, if we look up Google Cloud Bucket, yeah, they have this notion of cloud storage bucket. So let's look that up on Terraform. And we're actually, yeah, it's actually not too hard to find this storage bucket resource. And I think this is what we're going to use. I mean, I did a little bit of research beforehand, and, you know, I believe this is the closest mapping, and yeah, they support a lot of similar APIs. If you've used buckets in AWS, like some of this looks familiar. Obviously, there's like access control stuff. So we're looking for this Google Storage Bucket resource. Now, because in the SDK, we're, you know, one option is like to generate Terraform by hand. And Terraform actually comes in two formats, which are like, this is HCL, but you can also define it in like JSON. And so what we could do is like, say when you create a bucket, we create a new text file, you know, or like we could even, you know, do something super naive, like, you know, fs.write file and write the JSON file, you know, some huge object, some Terraform config here, right? And this would kind of do the job, but it wouldn't really compose it with all of the other resources you're already creating. And it'll also just be like a lot more work. So the CDK-TF framework kind of simplifies this for us, because we can actually just like import, let's see, it's a from, yeah, we just imported that thing. So provider Google, it's like kind of hard to find things here, but let's see if autocomplete helps us. We're looking for storage bucket.
Storage bucket.
Yeah, okay, you saw it. Good. And so we can import storage bucket that way. Now this is actually the thing I need to fix, but basically, if you try importing this entire CDKTF thing, it will actually like increase our build times by like at least 100%, because it's like such a crazy huge dependency, so that it turns out to be better if we just like do a barrel import. This is actually what they recommend. I want to add like some kind of ESLint rule so that people don't kind of it'll like tell people how to, yeah, people don't trip over this. But yeah, okay, so there's a storage bucket in this namespace that's like nested deep in this library. And we're gonna say new storage bucket. Say this, we'll just call it bucket. And then there's all these config options. And the first one we need is a name. So, I mean, naively, we could just call that bucket perhaps. Okay, what else? Oh, there needs to be a location. Yeah, there's some docs here on the Google Cloud.
ה-ID יכול להיות bucket. לא, כי זה היררכי.
But basically, like Google Cloud lets you like specify what kind of like region you want it in, and at least as a default, we can set to EU. That's fine. Maybe we have more people there. It doesn't really matter. But we actually do have to kind of pick a default here, which is kind of awkward from an API design perspective. But we can definitely add some ways to let people configure that or escape hatch it if they need. Something to think about. Because it's kind of an operational concern, right? But okay, so we have this. Now this bind method you'll see here, we kind of glossed over this, or we've ignored it up to now. This bind method is here for basically including the logic for if an in-flight references this bucket. Now for now, we're going to, I mean, that's like kind of one of the key, like really interesting parts of the Wing language. Like, you know, any resource can be referenced in flight and you can use in-flight operations, but we don't even have like a function resource yet. So for now, we're actually going to keep it as just like unimplemented. So it's just going to throw an error, and that's totally fine. I can silence these errors by just underscores here, but yeah, and here now we can finally say return new bucket. Oh wait, no, we want this bucket. Scope. What is this supposed to be? Why is this complaining? Oh, this should be just like construct. I think. And okay, all the errors seem to be gone. That's a good starting point. So do you want to try just synthesizing this and see what happens? Because we will run into errors. I think you'll actually find.
Chris, should we call the internal one default or resource?
Yeah, we can definitely call that default. Also, I think for the name here, like this actually needs to vary based on the bucket's ID. So this should be like ID probably.
Address.
Yeah, we could do that.
It must be something like address, because otherwise you're gonna create conflicts.
Yeah. Although, like, maybe there's an argument for making like a human readable name here.
So you can
know,
do ID plus address or something.
Yeah.
It,
Or you could
I-
also use the path, right?
I think that best practice with Terraform is to actually use their random generator. Are you familiar with that? If Terraform has this concept where it can generate random strings and store them in the state.
Hmm.
And that's usually a better practice when you, I think that might be a better, like we need to decide what's the class, what's the school solution here when a resource doesn't have an, you know, resource name is required, you know. It's an important, it's an important thing.
Yeah. For sake of being silly, I actually want to try this and kind of show off, like purposely implement a bug for live coding purposes, because it's it'll highlight something interesting about how Google Cloud works. So we're gonna try printing out this using this path as a name for the bucket. And for people that like aren't too familiar with what these paths are, it's like basically the entire. It's like a unique ID. It's like a name based on where this construct is within the construct tree. So we're building a tree of resources, and it's almost like a file system path. So let's like print that out just to, or we'll also see in the synthesized template actually. Okay, so let's close up some of this stuff. So, okay, so this was our file. We still, okay, so let's actually add a new cloud.bucket. And we're just gonna pass, you know, we're not gonna pass any props. Okay, and it's gonna generate some Terraform here. We see there's a Google provider, that looks good. And there's one resource in this template, which is a bucket. Awesome. And we see the location we specified, and this name we specified. This is the path that we were talking about. And like, it seems like it could make for a reasonable path, just as a hypothetical. I'm not saying it's a good idea, but okay. So now we want to actually try deploying this to see, like, you know, does this work? Like, is this valid Terraform and stuff? So saving some time for this demo as well, I've already installed the Google, like basically in order to deploy resources to Google Cloud, we need to have the Google Cloud SDK installed on our system. And you can do this via like Brew or like Cloud SDK. I'm gonna add some instructions in the README, or sorry, like in the contributing handbook for like if anyone wants to add GCP resources, like here's some steps. But basically, how does it say context sales? Just, oh, okay. But you really want to install this CLI, basically, this G Cloud CLI. And let's go back to VS Code. So G Cloud. Yeah, so we have this whole thing here. And there is a command that you like need to run to like to set up, you know, a token in your terminal so that like Terraform can automatically find your Google Cloud, you know, credentials and stuff. I did write it down so I can add it to the contributing guide, but like just to save time, and I don't want to leak credentials, I'm not going to show it here. But yeah, there's just like 2 steps there to get it working with Google Cloud. But let's try deploying this. So we have this deploy command, which will basically just run Terraform apply in this directory. Sorry, this is Xversion.
Sandbox deploy, no?
Yeah. Okay, let's this bigger. Okay, it's asking, do we want to provision this resource? Let's approve it. Okay. So that's our first error. So we need to set that project ID that we were talking about. So yeah, basically in this file, I don't know where it's even shown. But I think for here, basically for the provider, we need to actually specify some options for the provider, namely that project ID. So I believe the most logical place to put this is actually to configure it on the app. So we're gonna say, create some like,
You're on target TF right now.
we're just gonna add a prop that extends like, or we can call it like GCP app props for now. Oh gosh. And we're gonna say you have to pass a project ID.
Chris, wrong file.
Oh, thank you. Goodness.
Yeah,
Yeah, you're right.
noticed it.
Okay, we're in the wrong app. Okay. Base GCP app props.
This brings up an interesting question. Okay, I won't jump in.
Okay, but in this Google Cloud Provider, yeah, you can see there's a lot of options, even just for the provider. Like, do you want to customize? I mean, I don't know what all of these do. I really don't, but we do. But for now, I just know that the project ID, also the docs, they don't even show here, which is kind of unfortunate. But I think if we click on this link, it would tell us. Yeah, so basically we need to specify this value. And maybe we even want to allow people to select a region or something. It's a design question we have to consider. Oh, in this, I don't know why it's saying AWS. We can just call it Google or something. I don't know where that gets rendered, but okay. So let's just synthesize and see what changes in our output. Like, let's see that. But this is now going to fail, right? Because we need to specify ID. So, right. And we need to copy that from Google Cloud. Hello. Okay. Let's synthesize, see if it works. Okay, so we see the ID here. Let's try deploying again. And let's hope we get a bucket. No, okay. So yeah, with Terraform, like I think this is like normal stuff you'll encounter because you don't know how all the resources work. Fortunately, we're getting some nice error messages actually. So the bucket name validation failed. And we see it actually gives us this link. And it tells us that bucket names, can only contain these characters. It must be between 3 and 63 characters. So yeah, the issue was that we actually have like these slashes in the name. And so, yeah, I guess we could implement some kind of general naming mechanism here, but I will take a lad suggestion here, which was just to use, I think, the address, and this, you can see here, it returns an opaque true unique address, which is like 42 characters, hexadecimal. So this will totally be valid, I think. Okay, so let's see the ID. Okay, so the name, yeah, we see the new name here. So let's say approve. And the apply is complete. So let's see if it's appearing in the console. I don't know if it shows by default here. No, we need to probably go to storage. Cloud storage. I've actually never gotten this far, so this is all new to me. So, okay, so this is our bucket. Looks legit. We did it.
Yes.
Lap. So yeah, from here, there's the question of like, what do we want to do next? Do we want to support, public buckets? Obviously, yeah, this requires. I mean, probably you have to look up how GCP does that. Like I see this.
Sorry, go ahead.
Yeah.
No, I mean, here's something low-hanging fruit that I think is important and kind of relevant. Since buckets are stateful resources, right? And I think it makes sense to add lifecycle definition to the bucket. The Terraform has this thing called lifecycle. If you look at if you just like if you just go to the code and add lifecycle under the buckets, it'll show you.
Like prevent, destroy, that
exactly
kind of thing.
Exactly.
Okay, so like life cycle. Let's see what the type of this is. Okay, so it's this life cycle thing. Okay, and we could say prevent, destroy. That's probably a good idea.
Yeah. And I think this is something that we need to be a little bit more, that's definitely something that users sometimes want to configure globally, right? Like we don't want to say this is a test app, so I don't care if it's destroyed. Or there's, I think, also a way for you to specify to make it orphan, like in CloudFormation, where you can basically say, does disconnect from the stack, as opposed to preventing the stack from being destroyed, preventing the resource from being destroyed. So there's some work to do on the, yeah, exactly. Not necessarily prevent for Aptos, but basically allow some configurability around how stateful resources are protected as a general, as a high level, as a cloud level thing, right? We specified as a stateful resource, but then maybe there's a way to say that all stateful resources are protected or not protected or something like that.
Yeah.
And then
like
setting
the life cycle for like resources probably across the entire app makes the most sense.
Yeah.
Or at least that's the most common use case.
Yeah, but it's also something that you may want to do per bucket. So so I think that it's something that I would consider to add in the bucket, on the general purpose bucket props, the high level bucket props as an option. if
Yeah,
it's ephemeral or something like that.
right. Yeah, we've had this concept of like buckets that are just used for storing like, information that can be
Yeah,
regenerated easily and stuff that's holding user data. You definitely don't want that deleted in your production app,
yeah.
So
And then there's deletion of objects when you destroy them. That's another kind of aspect of buckets that anyone else.
yeah, totally. One more thing we could go into, like we have a little bit more time, is so now we've kind of implemented bucket in the SDK. How do you get it so that in a Wing file, new cloud.bucket, like if we bring cloud, that we can actually compile it to GCP. I'm not going to save this here, but so how does this mapping happening? Or how does this mapping happen? So we actually kind of have to configure that in the compiler right now. And it can't be like that forever, like because we want to let people support their own targets and stuff like that. But at least for now, like, do things that don't scale. The best way to maybe add that is to show how it's currently being, how it currently works. So let me actually like go to the mono repo, like the whole thing, and let me see if I can show like what gets generated here. Maybe. So basically, when the Wing compiler runs, it generates some JavaScript, based on the Wing file that looks like this. So a lot of this corresponds to the actual resources you've defined, but some of this is some boilerplate that, it's just just a mechanism we've added. We can change it in the future, or we'll probably need to change it. But you can see here, basically, it's basically the CLI will actually pass this environment variable for the Wing target. And then based on that, we'll actually kind of substitute in the right app class. So we want to change this code generation to say, if TF GCP is selected, then we return this new app class. And that way you can see like your app will just extend this and it will kind of all work dandy. Although actually it will be a little tricky because we need some mechanism for specifying the project ID. So actually, yeah, this might require a little bit of reworking.
Yeah, we were just saying that ideally the compiler would reflect on the app class and expose the various options on the app class as switches to the compiler.
Yeah, I think that's a good idea. Right, because the output directory you want to customize, the name. The name is like by default whatever the entry point file was, but yeah, all these options you want to configure.
The other thing we can do maybe temporarily, which is in a sense, if you think about it, it's not very different from how it works for the AWS target, is to just use a set of environment variables to set these things up. Think about it like AWS region, right? AWS region is set through an environment variable eventually. And so we can say, okay, GCP underscore project ID and GCP underscore region or whatever. Like that could be a good kind of temporary solution to set up those things.
Yeah, that's a good idea.
So that's
Yeah,
the default. So that's the default of the property in the app class. So if nobody's specified, it just falls back to the environment variable.
Yeah, so we could say this is optional and then say,
Yeah.
yeah.
Seems like
Yeah, I guess, yeah, Copilot already had.
Copilot listened to us and
So, okay, so that kind of unblocks us, which is cute. So this code, where does this get generated? Right now it's just some kind of string in our JSFI class. So yeah, we could tweak it here. GCP. And I think we've got a solid pull request here. Need to check if the test passed. Also, okay, we need to add tests. I'll do that. But maybe that's a good thing to go into just for a minute. Basically, yeah, we have these tests for each of our targets in the SDK. These are just for testing the SDK like by itself as a unit, like without the compiler, without this anything else. And we can see like here was the test that one of the tests we have for the AWS target, and it basically creates this app and then it makes some assertion on the list of resources that are generated, and it also takes some snapshots just to kind of see what it looks like. And so we're probably going to just do something super similar for GCP.
We haven't added an in-flight client yet, right?
Correct.
Next class.
Yeah, next class, the next session, I guess.
Amazing.
And yeah, also hopefully, we can kind of reduce some of this repetition, because ideally we'd also have like an integration test that like actually tries to deploy the bucket, and maybe that one integration test can we can just run that test per target, stuff like that. I think like that'll really reduce the amount of code people need to write for contributing resources, which will be a huge win. Also prevent a lot of these bugs where people like notice, oh, Terraform apply doesn't work in this weird situation. So yeah. Anything else?
Very cool, man. Very cool.
Okay. Well,
thank you, Chris. That's great.
When is it? We're not sure what the next session is. Maybe not next week, but we can definitely start thinking of when to do another. Also, I'd love to hear, if you have any feedback on like things to do to make this better, fun. Also, other people, I'd love to see maybe Yoav do a compiler session, or no pressure. Actually, I think he left, but
We also have these Monday hangouts every Monday. Well, I think we haven't. I don't think we've publicized them in our GitHub repo or something, or Slack. So we'll do that, and we're just going to have a hanging out for a couple of hours, for an hour or an hour, a couple of hours, I think, and sometimes coding, sometimes blabbering, sometimes just not doing anything. So EJ, you're welcome to join those as well.
Absolutely.
Good to see you here.
Yeah, same here.
Cool.
Cool.
Well, thanks everyone. Appreciate
Thanks,
it,
everyone.
audience.
Bye-bye.
Thanks,
Thank you so much, Chris.
Take it
Bye.
easy.
Brilliant. Bye-bye.
Bye.
Chris.